object-oriented programming, exception handling. So let's talk about errors and faults. Error anticipation has been and still is one of the hardest parts of software engineering. So there is no software that would be without any errors. And when error occurs, a program has to behave in a deviant way. So it can crash, but we don't want to build software that just crashes because there is some kind of error. So can rocket fly if data from one sensor is missing, or should it behave so that it can compensate for that missing data? Or if you are playing World of Warcraft, what should happen if the network loses some packages? So what could be the error handling there? Probably send the package again. And it is common that programs should continue working even if some faults exist. That is very true. If you are using Signal or WhatsApp or whatever, those softwares or mobile apps do not crash if you haven't turned your Wi-Fi or mobile data plan on. They just wait for the internet connection to come alive. And probably some operations under execution needs to be cancelled. So WhatsApp cannot send any messages until there is a network connection. And there are plenty of reasons to errors. So errors might happen already in requirement engineering. So after that, one can try to do some tasks with the software that is not possible. So there is a error in requirements. So then there can be errors in design. Some requirements have been missed. It has been in requirement engineering that there should be button A, but then in design the button A has got lost somehow, so then there is an error. And it means that the design of the implementation is faulty. Of course, we can have a implementation programming errors. So there is an actual mistake in the coding. And we can have error in third-party component. For example, Android library is returning an invalid object. So we are not getting what we should get from some method. And in programming, one cannot have an effect to the errors requirement in requirements engineering or design. So when you are programming, you need to trust that the design is okay, that the design is what we are really, what the customer is wanting. And what produces errors? There are two kinds of errors, hardware and software errors. So hardware errors, something like hard drive can be full. So then we cannot save any file to the hard drive, it's full. And programmer can, and actually it has to, he or she has to actually check that if the operating system informs errors on execution. So operating system will inform you that the hard drive is full, or mouse is not connected, or network connection is not available. These are provided by operating system. But of course there can be hardware errors that have happen even so that the operating system is not aware of them. So memory banks can be faulty, and then you are losing bits here and there, and the operating system does not see it, but it can produce well-functioning program. But usually these can be skipped because they are very, very rare. And then software errors. So basically you are building a function, but you are providing it with a wrong argument. So you are providing a function with float, and you should provide it integer to that function. So then there might be a software error. Or you are reading comma-separated value file, but it's not in correct format. There are too many commas or too less commas or something like that. You can run out of memory. You are running your program, it's eating all the memory, and then everything will crash. So what can a programmer do? Operating systems and libraries and frameworks provide tools to detect errors. And it's easy to detect errors, but it's programmer's job to develop procedures to overcome the errors. So operating system provides you a message that okay, there is an error and you should do something. But then the actual programmer needs to build this implementation. What should you do when there is an error? And programming is like driving a car. Even if you drive perfectly, someone else can still crash your car. So you need to be ready for that someone else is doing wrong, although you have been doing all the things right. And for example, user should input an integer, but she inputs a string. So although you have been providing a guidelines that please input an integer, you cannot be guaranteed that he or she is inputting an integer. So if there is a string, then the program has to handle that it is, for example, asking again that please input an integer value. And if you have a GPS off and you are starting a location app, then it should not crash, although the order of these steps is wrong. So Java forces programmers to prepare for some of the possible errors, and that is very good. So when you are programming with Java, you already know that there are errors, and the language forces you to do something about them. For example, if you are casting a string value to integer, you need to check that if there is a casting error. So how to react to an error? There is no right or wrong way to handle errors, and programmer needs to find the most suitable solution. There might be plenty of solutions, but it's programmer's job to find the most suitable one. It is okay to react errors in a component and handle them internally. That's fine, but it's also okay to just note the error and then throw it to the next component. And often the default way is to stop the program, so crash it. If you are doing nothing in your program, it will probably crash if there is some error. And it is definitely not the best way. How do you even know why it crashed if you haven't written anything log or put some message to the user that what would be the reason? If you are dividing number by 0 and you're dividing variable with the second variable, and the second variable is a 0, then the program will crash. So you should then inform the user that hey, you are trying to divide this number by 0 and it will crash the program. So it's better to log errors, free all resources and inform user, and then to stop the program, or even better than not to stop, just continue with a fixed way. And of course, one way is just to ignore the error, but it probably is not the best thing. But in some cases it might be okay. Usually not. So how are exception handling working in Java? Java offers an exception tree, and programmers can catch available exceptions. And we have been meeting this number format exception when strings are parsed to integers. Then there might be number format exception if the string is not in integer format. And here are just few exception classes. So basically the main class is throwable, so something can throw error. And then there is this super exception class, and it's divided into multiple subclasses. For example, IO exception, runtime exception, and then there are file not found exception, which is an IO exception, which is an exception. Similarly, there is an arithmetic exception, which is a runtime exception, which is an exception. But this is not the whole tree. There are plenty of already existing exceptions, which you can Google if you want to learn all those exceptions. And so exceptions can be divided into hierarchies based on where exception is related to. And exception handling can be divided on levels. So one part of the program handles overflow errors, another one handles null pointer exceptions, etc. Those can be handled in different parts of the program if that is the way the programmer wants to build his or her program. And you can model and implement your own exceptions just like classes, so it's no different from that. And here is our own exception class, and it's definitely not rocket science to build your own exception class, because the only thing you need to do is that you inherit this exception class. So here we have a bad email address exception, and it extends this exception class, and then there is just a constructor. There are two constructors, one taking no parameters and the second one taking a message, which it's then calling this super class constructor with the keyword super, and it's giving the message to that class. And throwing and catching an exception. So exception is thrown from try block with throw command. Very simple. We have been seeing that we will need to have a code inside try block, and then we can catch the error in a catch block. So there can be also this finally block, which is executed whether there was an exception or not. So it's always executed. So in this example we have a email address. First one is a dog@such_wow, which is a correct email address, and the second email address is cats_such.not, which is not a correct email address. So in the try block we check that if this email address contains, or if it's not containing, if it does not contain @sign, then we are throwing new bad email address exception with the message email address incorrect. And we are catching it in the catch clause. We get this ex variable, and then we can print out this exception get message, and we can also print the stack trace if we want, and then we can continue. We can do whatever we want to do with the exception happening. So basically this could be in a while loop, and you could get out of the while loop only after the email address is accepted. And more of these exceptions. So exceptions can be thrown from a sub part of the code and then catched in the upper part. So here we have some kind of a method that is throwing an exception, and then this try catch part is in other part of the code. We are just calling the method with these email addresses, and then this checkmail method can throw exception. And it's also possible to have multiple catch blocks, like here we are first catching bad email address exception and doing whatever we want to do with that, and then we are catching an exception, which is a general exception class, the main super class. So first, if we have an exception and it's bad email address exception, then it's catched there. But if it's some other error, then it's catched in the latter catch part. But be sure that you use more specific first and then the more general, so that the first catch block would not catch everything. So if we have this catch exception ex as the first exception catch, then it would catch everything, and the bad email address exception part would never be execute it. Let's have an example on these exceptions. So let's continue with this our rocket thingy, and we have now different rockets. And do we have a cargo here? We are not providing that much cargo. We have a few satellites and the moon rover. So now if we would have this starship and we would like to put a nuke there, so we could drop nuclear bombs to somewhere. And now we want to make sure that this is not possible. So you cannot put any nuclear devices as a cargo. So how do we do that? So let's build an exception class. Let's call it a illegal cargo exception, like this. And as this is an exception class, so it needs to extend exception, the superclass. And then let's just build a constructor there. And let's take a string as a parameter, and then we are just providing this string to the superclass. Very simple exception, so it's illegal cargo. And then let's move to the rocket class where we are adding cargo here. So let's build a check here. So if cargo, and yeah, this cargo is a string, so let's first make it to the lowercase letters like this, and then check that if it's containing some kind of a word or a string. So let's check that if there is a nuke included, or otherwise it could be also nice to check for nuclear, like this. And if there is a nuke, and well, anyways, we need to throw new error then, and no, this illegal cargo exception, and let's give it a message: no nukes allowed, like this. And there is a yeah, now it's working. So now we of course need to add this throw clause. So this method is throwing, it might be throwing illegal cargo exceptions. And now we can go to the main.java and see that there are some notification. So we should surround these cargoes to this try catch. We can just remove this line now. So, and now we are adding 3 pieces of cargo in the try block, and then in the catch block we are just telling user that something is wrong. So let's write a message. Exception happened. And then we can use this exception, and it has a get message which will provide us some kind of a message. So let's see what happens. Let's run this program. So we tried to put some stuff in the starship, but it said that exceptions happened, no nukes allowed. So no, this starship does not have nukes then. And here is the mention that there are satellite A and B, which were added to the cargo, but this nuke part is not present as it provided us an exception. It was skipped. So this is quite okay syntax to check that if there is something wrong and what should you do with that thing. You are just building some kind of exception and then you are throwing it when something happens, and now this nuke is being skipped and user is getting a message or the program is getting message. It's running this catch part and you can do the work you want to do there. What about exception versus if else? So if we are doing just programming, we could handle the errors just if the email address has this, and then if it has not, then let's do another thing. So what are the benefits of exceptions? So exceptions are a standard way to control possible errors. If there would not be exceptions, developers would use their own ways. So one developer would do it like that. If the divider is 0, then we are returning -1. So note that this is not okay. And someone could write a code that if DB connection is null, then return, and it's a string providing an error 44. So these are completely different ways to handle errors. Another one is, the first one is returning integer and the second one is returning string, and how could the user know what he or she would do with the error. So every programmer, company, library would have their own implementation, which would be not compatible with each other. So how would this component A take care of error from component B if the component A would use this -1 type, and then it would use the component B which would provide an error 44 string? What would happen? Probably crash. So exceptions are a universal and simple way to tackle the problem. And Oracle has an excellent example, so you can check that out and find out why the exception way is way better than this if-else syntax. So as a summary, exception handling in Java is very common. So you're using exceptions everywhere when you are programming with Java. And developers can build their own exception classes as much as they want. And exceptions are the correct way to communicate errors to other parts of the code.